Okay, so since I've had you do so many proofs, this homework assignment and the last homework assignment, I'm not going to give you another one with more proofs. Just make sure you understand the process for these. So after you've done them, go over them. That's how you can kind of study for it to make sure you understand how it works. Because I think the biggest issue is the mathematics. A lot of you can change these identities to other identities, but it's the algebra that's getting you. So I figured I'll go over 4 of them, the 4 I circled, just so you get a little bit of an idea of the mathematics behind some of these and to make sure you're doing at least some of them right. And then if you have finished this page, I gave the sub an answer key. It's written really small, so it's going to be a little bit hard to read, so you can try to follow it. But that's how you can check some of the work for this page. Okay, so I'm going to start with question 4. So I'll write it up here. So it is cosine. I'm just going to write the cosines and sines right now instead of the letters, just to save some time and space on here. Okay, so with this one, I know a lot of you are thinking you can just distribute like this, but you cannot because they are added together, right? If I have x squared expanded out, that's x. That's 2 x's. And so this is just sine and cosine times itself. So you'll have cosine minus sine times cosine minus sine plus cosine plus sine times cosine plus sine equals 2. Okay, so we have to distribute. So we're going to get cosine squared minus cosine sine minus cosine sine, right, because that's the second one. And the last one is plus sine squared. Okay, then we're going to have a plus sign here, so plus, distribute again, cosine squared plus cosine sine plus cosine sine, and I'm going to have to write it down here, plus sine squared equals 2. Okay, well I got a negative cosine squared, a negative cosine, or cosine sine, negative cosine sine, positive cosine sine, a positive cosine sine. So yes, those all cancel out. So now I have cosine squared plus sine squared. All right, that's these ones. But I also have, again, plus cosine squared plus sine squared equals 2. Sorry. Well, what does cosine squared plus sine squared equal? That equals 1. This one also equals 1. Well, 1 plus 1 equals 2. So there is the proof. Down to our final answer, okay? So again, this one's just the mathematics, okay? Understanding it's the same math we've been doing all year, especially with polynomials. So distributing, factoring, multiplying, dividing, adding fractions, subtracting fractions, all that stuff you've been doing all year still applies with these sines and cosines, okay? So that's question 4. Let's look at question 6. So question 6 is, it's not working. 6 is tangent squared over secant plus 1 equals 1 minus cosine over cosine. Okay. So the biggest thing in guiding me of what to do is that right there. Okay? That is not secant squared. We cannot use a Pythagorean identity. We don't want to have secant plus 1 because we can't do anything with that. So we have to get rid of it. And the only way to get rid of that is by multiplying it by its difference of squares. So remember, difference of squares means I'm going to multiply it by secant minus 1. Same thing, just different sign. But what I do to the bottom, I need to times the top. Okay, so I'm not going to distribute the top just because I want to see if anything cancels out. So I'm going to have secant minus 1. I can always do it later, distribute later, times tangent squared. But on the bottom, I'm going to have secant squared plus secant minus secant minus 1. Okay? And then this all equals 1 minus cosine over cosine. Okay, so now those are going to cancel out. And what does secant minus 1 equal? Well, that just equals secant squared minus 1 equals tangent, right? Whenever we have a squared, we should be looking at Pythagorean identities. So now we have a tangent squared on the bottom. Okay. So now those cancel out and we're just left with this. So now let's look at this side. Okay? Because this side is obviously as simplified as it can get. We got a secant minus 1. It's not a fraction anymore since the tangents canceled out, so we can't times by a difference of squares. So over here, what this means is that 1 is being divided by cosine, and cosine is being divided by cosine, right? Everything on the top is being divided by cosine. So what does cosine over cosine simplify to be? Well, that just simplifies to be then negative 1. And what can we change that to be? Well, it's reciprocal, secant. Well, what's our other side equal? Secant minus 1. So now they match, and we're done. So that wasn't too bad. Okay. Next one. Number 7. So we got tangent squared over, oh sorry, I was looking at the top one above it. Tangent squared minus sine squared equals tangent squared times sine squared. Okay. So, tangent minus sine. Well, there's no way we can combine those together. There's nothing we can really change. So I'm just going to make this into some sines and cosines, right? When in doubt, turn them into sines and cosines. So now I have sine squared over cosine squared minus sine squared. And just to keep up with the fact that it's a fraction, I'll make it a fraction. Tangent squared, sine squared. Okay. So, the nice thing is we can combine fractions. In order to combine fractions, we have to have the same denominator. So we need to times this by cosine squared. So they have the same denominator. So what I have is sine squared minus sine squared times, right? These are times together, cosine squared over cosine squared. Okay, and that still equals tangent squared and sine squared. Now I know a lot of you are going to be tempted to just those subtract out. Can't do that. This sine is attached to that cosine. They're multiplied together. Okay, so that means these are not like terms. It's like this is an x minus xy. Are those like terms? No, they're not. So you cannot combine them together. Okay, so what we can do though is if I have an x minus xy, I can factor out an x. So in this case, we're gonna factor out a sine. So if I take a sine out, or sine squared actually, sorry, sine squared, what's sine squared divided by sine squared? That's 1. What's sine, and then if I take a sine squared out here, all I'm left with is cosine squared. and that's all over cosine squared, equals tangent squared times sine squared. Okay. Nice thing is, what does this equal? Sine over cosine. That equals tangent squared. And what does this equal? That equals sine squared. And voila, we have tangent squared times sine squared now. Okay, so we're done. Okay, last one. I'm running out of room, so I'm gonna just erase question 4. So if you need to take a picture of question 4, I'll give you a second. But I am going to erase question 4 and write question 9 up there. Okay. Question 9. Sine over 1 plus cosine plus 1 plus cosine over sine equals 2 secant, or cosecant. Okay. Again, that tells me I have to do difference of squares. So I'm going to be timesing it by 1 minus cosine, right? Same thing, just a different sign. Timesing it by 1 minus cosine. Okay, I'm not timesing the top yet. I'm not going to distribute it yet, just in case. But on the bottom, we got 1 times 1, 1 times cosine, minus cosine squared. Okay. Plus 1 plus cosine over sine equals 2 cosecant. Now, some of you might have combined fractions together. That is totally fine. That's something you can also do right away, is combine fractions, right? Because that's positives. Okay. You can totally do that. I just did the 1 minus cosine because in a second these cancel out, and what does the leftover turn into? Sine, right? Sine squared. So I have sine 1 minus cosine over sine squared plus 1 plus cosine over sine equals 2 cosecant. And so it just works out nicely in this one that those cancel out, and now we have the same denominator. So I can easily put these together, right? So I'll have 1 minus, so here I have 1 minus cosine on top, plus 1 plus cosine on top, and then, right, we have to keep the same denominator, so it's still going to be sine. And so the nice thing is the cosines cancel out, the ones come together. Oh wait, I forgot to write that this equals 2 cosecant. So now I'm left with 2 on top over sine equals 2 cosecant. Okay, which sine is then cosecant. So with all of these proofs, there's always multiple ways you can do it, different steps. Like I said, you could have combined the fractions first. That's totally fine. As long as your math is correct and you're not just making up rules and making up different ways to do things, and your identities actually equal the correct identities you change them into, then it doesn't matter the process you do it, okay? So, those were those 4. Like I said, if you want to check the answer key, you can. The sub has it. Just make sure you understand and can think through these. One good thing to study is while you're studying these, once you've already done them and you're reading through them, just ask yourself, why could I do that? Or why did I do that? Okay? Because if you're understanding why and how that works, hopefully you'll understand it better and remember it, because this is not something you can just memorize a process. There's those tips to help you, like changing things to sine and cosine, using difference of squares, but you need to make sure you can kind of understand what's going on.